Here in types of function, third one is onto or subjective function. What is first one? One function. Second one is what? That is many one function. Third one is onto or subjective function. What is this function? You see, a function f x2y is said to be onto or subjective if every element of y is the image of some element of x under the map of f. So, if you take these are the function, this is x, this is function from x to y, this is y diagram, y set, this is x1 have the elements x1, x2, y1, y have the elements y1, y2. So, mapping from x to y, map, this is x3 is there, x3 have the map here, this one. Okay, so like this, this is f x2y is the onto function. Onto function or subjective function means every element of y, every element in y is the image with image of some element in x. Imagine some element in x, that is the f x2y is onto function. Means what? Every element in y is the image, that is the range of f equal to codomain of f is a codomain of f is a if range of f is equal to codomain of f, then it is said to be onto function or subjective function. Once again, definition: a function f x2y is said to be onto or subjective if every element of y is the image of some element of x under the map of f. So, this is the onto function or subjective function. Okay, all of you. That's all. Dear viewers, one more important result. A function f x2y is an into function if it is not onto function. Suppose it is into function, it may have, may not have onto function. This is the complete information. If x and y are any two finite sets having m and n elements respectively, where 1 less than or equal to n less than or equal to m, then the number of onto functions from x to y is given by here sigma r is equal to 1 to n minus 1 whole power n minus r ncr a r power m. This is the important result. Number of onto function from x to y, sigma r is equal to 1 to n minus 1 whole power n minus r ncr r power m. This is the result. Okay, all of you. That's all. Some of the points in into function. The number of into functions from a to b is given by nc1 n minus 1 whole power n minus nc2 n minus 2 whole power n plus nc1 n minus 3 whole power n and so on. If n minus a greater than or equal to n minus b and n minus b is equal to 2, then the number of onto functions from a to b are 2 power number of a minus 2. Any polynomial functions f is onto if degree is odd and into degree if f is into if degree of f is even. Polynomial function degree odd degree is there, then it is onto function. Onto means what? One function. Otherwise, it is into function, means subjective function. Okay, all of you. That's all. Here, rule for checking whether the function fx2y onto or into. Onto means subjective, into means one function. Find the range of the function f. If range of f is equal to y, then f is onto function. Onto function means subjective function. Otherwise it is into. Into means one function. One function, it is subjective function. Subjective function. Okay, all of it. That's all. Here, fourth type of function, bijective. What is bijective? A function fx2y is said to be a bijective if f is both 1 and onto. The function f is both 1 function and onto function. 1 means into function, onto function. So conditions satisfies these both functions. Conditions satisfy a function f(x) to y, then it is said to be bijective function. Then it is said to be bijective function. Okay, all of you. That's all. Here, if x and y are any two finite sets having the same number of elements, say n, then the number of bijective functions from x to y is n factorial. Bijective functions from x to y is n factorial. Okay, all of you. That's all. Here we have the problem. The number of relations from A, set A is equal to 1, 2, 3 to set B 1, 6, 8, 10. So here number of A is equal to what? 3. Number of B is equal to what? 4. So we have the number of relations. Number of relations are 2 power number of A into number of B is equal to 2 power 3 into 4, 2 power 12. So we have the option 3 is the answer. Okay, all of you. That's all. Here we have the second problem. The number of functions that can be defined from A, set -1, 0, 1 to B, set 2, 7, 8, 9 is. So here number of A is equal to what? 3. Number of B is equal to what? 4. Then number of functions from A to B are, that is equal to number of B power number of A is equal to what is number of B? 4. 4 power 3. 4 into 4 into 4. 4 into 4, 16. 16 4 ja 64. So we have the option 4 is the answer. Okay, all of you. That's all. Here we have the problem. Number of relations from A, set 2, 6 to B, set 1, 3, 6, 7 that are not functions from A to B. So here first number of A is equal to what? 2. Number of B is equal to what? 4. So number of relations, first relations A to B is equal to what? 2 power number of A into number of B is equal to 2 power 2 into 4 is equal to 2 power 8. Okay, all of you. So now what are the number of relations? Number of functions from A to B is equal to what? Number of B power number of A is equal to what is number of B? 4 power number of A 2 is equal to 16. Only from total relations. Relations means sum of the relations functions, sum of the only relations. That's why we want to only number of relations from A to B, not function. So only relations from A to B is equal to number of relations minus number of functions equal to what? This number of relations 2 power 8 minus this is 2 power 4. 2 power 4 power 16 means 2 square power square 2 power 4. Here 2 power 4 cancel. This is 2 power 4 minus 1. This value 2 power 4 is 16. 16 minus 1 15. So 15 into 2 power 4. So this is 15 into 60 is equal to what? 240. So 240. So option 1 is the answer. Okay, all of you. Option 1 is the answer. Here we have the problem. In a class there are 21 students, each of whom will get one of the grades A, B, C, D or E. Then the number of functions that can be defined from the set of students to the set of grades is. These are the options given. So number of A is the students is equal to what? 21 students are there. Number of grades B is equal to 1, 2, 3, 4, 5. 5 grades are there. Then number of functions formed from students to grades is the number of functions from A to B or is equal to what? Number of B power number of A is equal to what is number of B? 5 power 21. So we have the option 4 is the answer. 5 power 21 is the answer. Okay, all of you. Here we have the problem. The number of 1 functions that can be defined from A 1 2 3 to B A E I O U is. So here number of A is equal to what? 3. Number of B is equal to what? 1, 2, 3, 4, 5. Okay, all of you. So here 1 function from A to B. Now 1 functions from A to B. So that is number of A is equal to P. Number of B is equal to Q. Then 1 functions are what? That is number of functions are Q, P, this is M. You take this is N. So N, P, M. So this one. So like this, what is the 1 function is equal to 5P3 is equal to 5 factorial by 5 minus 3 factorial, like this. So we have 5P3, option 3 is the answer. Okay, all of you. That's all. We have the problem. The number of injections from A, set A 1, 3, 5, 6 to B, set B 2, 8, 11. So injections means what? Injections means 1 function. Here you observe, this is the function A. Function A 1, 3, 5, 6. This is A function. Function B 2, 8, 11. So F is function from A to B. 1 have and 2 have, 5 have. But what about A 6? So here number of A is equal to what? number of A is equal to 4, number of B is equal to 3. Number of A greater than number of B. Number of A greater than number of B. So we can't do 1 function. So that's why number of 1 functions are 0. So option 4 is the answer. Okay, all of you. That's all. Here we have the problem. The number of 1 functions that can be defined from A 4, 8, 12, 16 to B is 5040. Then number of B is equal to. Here number of A is equal to what? 4. Number of B we don't know, that is n. Number of A is equal to 4. Number of B is equal to n. Then what we can written as, that is number of 1 functions from A to B are what? NP4. NP4 is equal to what? 5440. 5040 is given. So NP4 means n factorial by n minus 4 factorial is equal to 5040. So n factorial is equal to n into n minus 1 into n minus 3 into n minus 4 factorial by n minus 4 factorial equal to 5040. This one cancel. So here n into n minus 1 into n minus 2. This is n minus 2 into n minus 3 into n minus 4. N minus 2 into n minus 3 equal to. This can be written as 10 into 9 into 8 into 1, 2, 3, 4, 7. So what is n? N is equal to 10. So we have the option 4 is the answer. Okay, all of you. That's all. Here we have the problem. The number of possible many to 1 functions from A 6, 36 to B 1, 2, 3, 4, 5 is. So here number of A is equal to 2, number of B is equal to 5. So what are the functions? So number of possible many 1 function, many to 1 functions is equal to number of B power number of A minus that is number of B P to number of A, that is number of B 5 power 2 minus number of B 5P 2 equal to 5 square is equal to 25 minus 5P2 5 factorial by 2 factorial. 25 minus 5 into 4 into 3 into 2 factorial by 2 factorial. 5 minus 2, this is 3 factorial, sorry. This is into, this is 3 factorial by 3 factorial. This one cancels. Thus is 25 minus 20 equal to 5. Only 5 or option 3 is the answer. Okay, all of you. That's all.